All right, good morning, everybody. So thank you all for being here on the Friday morning before reading week. So you're going to get your quizzes back after reading week, so probably the Monday back, hopefully. I've got like 400? I have something like 400 quizzes to mark over reading week in this class and another. They should get done. If they don't get done by Monday, they'll be done by the Wednesday? Is that when we're in? I don't remember what day we're in. They'll be done by the second class after reading week for sure. Hopefully they'll be done during reading week and you'll get your mark over reading week. So for today, I just want to, so we finished off lecture deck number 9. I'm going to jump ahead to 11 for a few slides and then I'm going to jump back to 10. So in one of the previous lectures, from I guess the most recent one or the one before, we were doing something with a list, with an array list. And I switched array list to this other type called list. And I told you that I would explain why in the next lecture or a few lectures later. And so this is the next lecture. So the list is what's called, in Java, it's called an interface. Right? So we haven't seen these before in the course. Right? So what an interface is, it's a specification, but it's not an implementation of a type. Right? And so what it means is that the interface says what methods the type must have, right? And it says what the methods must do, right? So that's what we mean by specification, right? What methods exist and what the methods are supposed to do, right? But the interface does not say how are the methods implemented, right? And so in other words, if you look at the methods inside the interface, there's no body of the method, right? There's no implementation. Right? So the list interface is an interface that says what methods every list type must provide. So in order to use an interface, you need to also, usually when you use an interface, you need a class that implements the interface, right? So you need the interface itself, and then you need a class that provides the methods that the interface says it must provide, right? So a class that implements an interface must provide an implementation of every method in the interface, right? That's true enough for now. Right? It's not exactly true, but that's true enough for now. Right? So for example, the array list type that we've seen in class, right, that must provide every method that's in the list interface. So in Java, an interface is also a type, right? So it's a reference data type. And what that means is that you can make a variable whose type is an interface, right? And so if you remember back to that list method that I showed you, it returned, one of the methods returned a list, one of the methods took a list as input, right? It didn't take an array list as input, right? It took a list as input. It didn't return an array list, it returned a list, right? The reason you can do that is because lists are reference types. So I can make a variable or a parameter, right? In this case, t, whose type happens to be a list of string. Now, in order to make an object that I can store a reference to in t, right, I have to make something that is actually a list class type, so like array list. Right? Array list is one of the classes that implement the list interface. Right? In 2 lectures from now, you'll see something called map, which is which corresponds to a Python dictionary. Right? And we'll talk about that in a couple of lectures. In Java, there's a bunch of these collection type classes that form what are called the Java collection framework. Right? And so the framework is made up of a bunch of interfaces, right? So you've got this thing called list that defines what all lists must do. Right? You've got this thing called set that defines what all sets must do, and you've got this thing called map that defines what all maps or dictionaries must do. Right? And then the library also provides you with a bunch of classes that implement these interfaces. And then furthermore, the collection framework also provides a bunch of algorithms that operate on the collections. Right? So for example, if you want to sort a list, there's a method that sorts a list. Right? If you want to search a list, there's a method that searches a list, and so on and so on and so forth. And so you can draw the picture of the interfaces in the framework like the following. So this is what's called a UML class diagram. We're going to look more at UML later in the course. Right? So UML is short for Unified Modeling Language. It's a visual language that describes that can be used to describe the architecture of software, object-oriented software. Okay. So what this picture is trying to show you is that there's something called a collection interface. So a collection is just a collection of stuff. Right? It's not a sequence, right? So it's not a numbered sequence of stuff. It's just a collection of stuff, right? Where the stuff are called elements. This arrow coming from list to collection says that a list is a kind of interface. A list is a type of collection. Right? And so what this means is that everything that's in the collection interface is also in the list interface. Right? And then there's this thing called set. Right? If you follow the line, you get to the arrow, and that says that a set is a kind of collection. Right? So every method in collection is also in set. Right? And then you've got this thing down here called sorted set. Follow the arrow up to set, and that says sorted set is a kind of set. So a sorted set supports everything that a set can do, which supports everything that a collection can do. Right? But a sorted set is special, right? As its name implies, it's sorted. Right? So if you iterate over the elements of a sorted set, it iterates in some sort of order. Right? So the things shown in red, those are all interfaces. The interfaces include all of the methods that are in collection. Right? So all of these things in red, if you follow the arrow up, you get to collection. Right? And that just means that the set, list, and queue interfaces, they all include whatever methods are in collection. They are allowed to add their own methods. Right? So there might be a method in list that's not in collection. Right? There might be a method in queue that's not in collection. Right? Going across, there's no relationship. Right? So if list adds if list adds a new method, that doesn't mean that set also adds that new method. Right? So across, there's no relationship, but up and down there is. And similarly to what I just said, the sorted set interface has every method that's in the set interface. Right? If it wanted to, it could add extra methods compared to set. We'll ignore this for now. We'll come back to map later. But the map type, or the dictionary type in Java, is completely separate from the other collections. Okay, so what's a collection? Well, a collection is just a bunch of stuff. Right? There could be duplicate elements in the bunch of stuff. There may not be duplicate elements in the bunch of stuff. Right? So a collection is just a group of elements where each object is a group of objects where each object is called an element. Right? And so the collection interface defines the most general operations that someone can ask a collection to perform. Right? So if you had a collection of stuff, what might you want to ask the collection? Right? Well, you might want to know its size. Right? How many elements are in the collection? Right? Is the collection empty or not? Right? You might want to search the collection. Right? So does it contain a particular object? Right? You might want to add an element to a collection, and you might want to remove an element from a collection. Notice that these methods are marked as being optional. Right? So it's not true that every collection can add an object to it. Right? So for example, you might want a collection that's always empty. Right? In which case, you would not want to be able to add an element to that collection. Right? Why do you want it to be always empty? Because you might want to return that collection in case, from a method in case the method fails for some reason. Right? And you don't want to throw an exception. We'll look at iterator later in the course, right? And then you've got a bunch of other methods as well, right? They're not exactly what these methods do at this point in time aren't important, right? What's important is that a collection represents a bunch of stuff, and then any class that implements the collection interface must provide all of those methods that are shown there. Right? So list is a type of collection. So what does that mean? List has every method that's here. Now, the list type says that it's a collection, but there's extra stuff that the collection can do. Right? So for example, the list interface says that it's a collection, and it's also a sequence. Right? So it's a number, it has every element in the collection has a unique index. Right? And that means you have positional access to every element in the collection. Right? I can specify an index, get a corresponding element from the collection. We can search the collection by its index, right? So I can ask for the index of a particular element. Right? Iteration we'll look at later, but for now, iteration just means that you can write a for each loop, and you can loop over the elements of the list. Right? Range view, that's what are called these range operations on the list. So sublist, for example, is one of the range view operations. Right? I can take a sublist of a list and get part of the list out. Right? So the list, we say it extends the collection interface. Right? As soon as you say extends collection, that means that list gets all of the methods that are also in collection. Right? So you get the size, is empty, add, and remove are all in the list interface. Right? And now the list interface adds its own methods. Right? So I can get an element by index. I can set an element by index. Right? I can add an element to the end of the collection. Right? I can add an element somewhere in the middle of the list, and so on and so on and so forth. Right? And so all of the methods that I showed you in ArrayList, well, this is where they come from. They come from the list interface. Right? Okay, so we'll come back. So that's all I want to say for now. Oh wait, I guess I should tell you about set, because that's the topic for today. So the set interface, right? Set is a collection where the elements are not allowed to be duplicated. Right? And so that represents the, or that models the mathematical set abstraction. Right? And so anything you can do with a mathematical set, you can probably do with a Java set. Right? So you can compute the set union, the set intersection, and the set difference. The set interface only contains the methods from the collection interface. Right? And then it adds the restriction that you cannot have duplicated elements in the set. Right? So set, its interface is the same as collection. Right? I can ask for the size of the set. I can ask, is it empty? Right? Does it contain an element? Right? And so on and so on and so on. In its add method, right, the add method says that you cannot add the same two elements that are equal to the set. Right? Because the set is supposed to represent a collection of unique elements. Right? And so set is what I want to talk about today. So that's the lecture deck 10. Okay, let me just jump back to ArrayList for a second though. So I've got this, I just cooked up this little class here before the lecture. Right? And so what we've been writing up until now looks like that. Right? If I want a list, I make an array list. Right? So I write array list equals new array list, and then I do something with the array list. Right? So here I'm going to add the values 0.0 through 9.0, and then I'm just going to print the list. Right? So we know that that array list has this add method, adds an element to the end of the list. Right? So if you run that piece of code, right, you get the array list whose values are 0 through 9. Okay, so now that you know about interfaces, right, you know that you can make a variable, in this case t, right, whose type is list. Right? So if I delete the array list and write in list instead, right, if you look at the editor, Eclipse is not complaining that there's any errors. Right? So as far as Eclipse is concerned, or I guess as far as the compiler is concerned, this is perfectly valid Java code. Right? And so now I can run this. And you get the exact same output, which not surprising. Right. And so we see here that the array list type, right, it's what we say is substitutable for the list type. Right? So when I say list double t, right, that says that t can hold a reference to any list. So can it hold a reference to an array list? The answer is yes, it can hold a reference to an array list because an array list is a kind of list. Right? And so this theme of substitutability is going to occur over and over and over again as we progress through the course. Right? It's one of the main strengths of the object-oriented programming paradigm. Right? You can substitute different types for a certain type. Right? So for example, I don't have to use array list, I can use a different kind of list. Right? So Java has something called a linked list. Right? So now I can change the thing I can change the type on the right-hand side of the assignment. Right? So a linked list is also a kind of list. So I can make a linked list object and store a reference to that in a list variable. Again, if you look at the editor, there's no errors, right? Save the code, run the code, you get the exact same result. Okay. Produces the exact same output. Right? You might want to ask, so why do I care if there's, like, why would I ever want multiple kinds of lists? Right? And it turns out that the answer is because the different kinds of lists, they perform certain operations more efficiently than other types. Right? So for array list, I can get or set an element in O1 time. Right? It's constant time. For linked list, I can't do that. Right? If I want to get or set an element by its index in array list, right, it's O(n) time, right, where n is the size of the list. Right? If I use array list and I want to remove or add an element somewhere in the middle of the list, that's O(n) time. Right? But if I use a linked list and I'm at the element where I want to insert or remove, then I can do that operation in O1 time. Right? So the different kinds of lists, they support different types of, they can support different kinds of operations. Right? And furthermore, the operations that they perform, they may be able to perform those operations more efficiently or in a different way than other types. Right? And so this gives the programmer the flexibility to choose the appropriate type of list for their problem. Okay, so let's look at the set type for today. I'm guessing that they didn't show you a proper set type in Python in 121. You might have seen one, but it's a bit uncommon to use just a plain old set. Okay. I'm going to tell you why. I'm going to talk about set anyway, because you need to know about sets in order to use the Java version of a dictionary. Okay. So sets are collections of unique elements, right? No two elements in the collection are equal to one another. So why would you want to set? Well, you might want to set when you really have to, when you have a collection of stuff and you need to make sure that there's no two duplicate elements in the set. Right? So for example, if you're building a dictionary of the English language, right, you probably want to make sure that there's no two entries that are the same. Right? You don't want to have to duplicate words in your dictionary. Right? So common uses of sets are things like membership testing. Right? So is an element a member of the set? Right? If you have a list and you want to remove the duplicate elements from the list, you can just pass it to a set, and the set will get rid of the duplicate elements for you. Right? And then if you have to compute something that looks like a set intersection, union, or difference, then set's your type, right? It'll do those operations for you. List won't do those operations for you, right? You'd have to write your own code in order to compute the intersection, union, or difference. Right? Furthermore, if you want to use a map, you have to know how to use a set in Java. So we have to talk about sets before we can talk about maps. The weird thing about set, especially if you're coming from Python or a language like C, right, is that there's no indexing on a set. Right? So you've got a collection of elements, but there's no way for me to get a particular element by its index. Right? In fact, the only way you can get anything out of a set is to know that that thing is already in the set, which sounds a bit weird, but that's how you use a set. Right? So there's no indexing, and you cannot slice using an index. Right? But some types of sets do support slicing in a form, right? And we'll look at that in a short. Will we look at it? We might see an example of that in this lecture. Okay, so Java sets provide similar functionality to basically mathematical sets, right? But you are allowed to choose from different kinds of implementations, right? So I can choose to use a hash set, or you can choose to use a tree set. There's other types of sets as well. Right? If you use the Python set, right, then the Java set that's most closely related to the Python set is hash set. A tree set is a set where the elements are always sorted. Right? So the set itself keeps its elements in sorted order. Right? So again, if you're going to build something like a dictionary, tree set probably the type you want. A tree set is a type that you might want to consider. Right? The words all get kept in sorted order, which is handy if you have a dictionary. Okay, so the set type, like the list type, is generic. Right? So to use the set type, you need to say what is the type of the element that's in the set. Right? So again, you have to use this funny left or angled bracket notation, right, to declare the element type. Right? So for example, when I make a set T, right, I can make a hash set right? So I call the hash set constructor. If it's a set of strings, then I also then I want to make a set. Then I want to call the constructor specifying that it's a set of strings. In a more modern version of Java, you can leave out the element type on the right-hand side, right? So I can leave that out right there, and just say hash set string when I declare the variable, right? So that makes a hash set whose element type is string. So hash set is normally the set that you reach for if you need to use a set, right? It is the fastest of all of the sets. Right? So just like with lists, right? You can't make a set whose type is primitive, whose element type is primitive, right? So there's no hash set of int. You have to use the wrapper type instead, right? So there is a hash set of integer. Right? It's the exact same rule as with the array list. Okay, so what can you do with sets? Well, I can make a set, right? So make an empty set, just call the set constructor, right? And pass in no argument here, right? Is the set empty? Well, that's just the isEmpty method, right? How big is the set? That's just size, right? So these are all the same methods that we used for list. Right? How do I add something to a set? Well, you just call add, right? Again, exactly the same as with list. Right? Does the set contain a value? Right? So the method is called contains. Also, exactly the same as list. Right? For the set types, contains is very fast. Right? So for hash set, it's O1, where it's O1 complexity. For tree set, it's O log n, where n is the number of elements in the set. Right? So contains is very fast for the set for the different types of sets. Right? Remove. You can remove an element as long as you know it's in the set, right? So remove elem, where elem is one of the elements in the set, we'll remove the element. Right? If elem is not in the set, if elem is not in the set, remove returns false. Right? And if you want to copy a set, well, you just call the copy constructor for set. Right? So exactly the same as with the list, right? I want to copy t, just pass t to the constructor of hash set. Sorry. To the constructor of hash set, and that will copy the set t. Okay, so when you make a set, you usually choose between 2 or 3 different kinds of sets, right? And there are actually more sets that you could use. Right? You almost always want to use hash set. Right? It's fundamental operations. So add, remove, and contains. Those are the primary methods for sets, right? Those all have O1, expected complexity. Right? Now the problem with hash set is if you make a hash set and then you iterate over the elements of the set, you have no idea what order the elements are kept in. Right? So if you iterate over the elements of the set, it might come out in one order. If you add or remove elements from the set and then you iterate again, they might come out in a different order. Right? So there are no guarantees to the iteration order of the set. Right? If you modify the set, the iteration order can change. Your other common choice is tree set. Right? So tree set also has fast add, remove, contains, but it's slower than hash set. Right? So O log n complexity. Right? Why is it slower? Because it has to keep everything in sorted order. Right? So when you remove something, it has to remove the element and then make sure everything is still sorted after it does the removal. Right? Similarly, if it adds something to the set, right, when it inserts it into the set, it has to make sure that it's inserted in the proper place. So the elements are ordered by what's called their natural ordering, so they're sorted. Right? We'll ignore this, so just ignore that third point for now. Right? So there's another kind of set that is occasionally useful. So there's something called linked hash set. Right? So just like hash set, it has very fast add, remove, contains, right? So O1 expected complexity. Slightly slower, though, than hash set. Unlike hash set, the linked hash set guarantees its iteration order, right? It says the order that the elements are iterated in is the same as in which the elements were inserted, right? So you add a bunch of stuff to the list when it to the set. When it iterates over a linked hash set, it iterates in the order in which they were added. How does this work? Well, it turns out that inside this linked hash set, it's just a hash set, but there's a list inside of it as well that remembers what order you put the elements in. Right? So basically, it takes up an extra amount of memory that's proportional to the number of elements in the set. Right? Internally, it's got a list as well. Okay, so sets don't support indexing, right? So it's really weird when you use them for the first time because you say, well, I want to get this element from the set, right? And there's no way to do it, right? What you have to remember is that if you're using a set and you want to get a particular element, then you know that that element is already there, so you don't have to get it anyway. If you want to iterate over the set, though, you can just use a for each loop. Right? You can't use a counting style loop, right? Because the index isn't used by the set, right? There is no indexing in a set. So typically, you use either a for each loop. I don't think I show you the yeah I don't. Or you use something called an iterator, and we'll talk about iterators later in the course. Okay, so what are sets useful for? Right? So one of the things they're useful for is you have a list of stuff, and you want to remove the duplicates from the list of stuff, or you want to find what the duplicated elements are, or you want to find what the unique elements are. Right? All of these problems can be solved with a set. Right? So suppose I have a list. I want to find all the elements that are duplicated, right? So all the elements that occur one or more times in the list, right? And then so you can just make a set, put all the elements from the list into the set, and the set gets rid of all the duplicates, right? Okay, so imagine you have a list of computing science account student name, CS account. So basically these would be your on-queue usernames. Right? So I've got a list of all the usernames of students in the class, and I'd like to know, right, or I want to make sure that the usernames are all unique. Right? So how would I solve this if I only had list? Well, I'd have to iterate over the list looking for duplicated elements. Right? And in fact, you'd have to use you need a nested loop to find the duplicated elements. Right? That's O(n) squared. If you to solve that problem with a list. Right? But if I take the list and pass it to the set constructor, right? What the set constructor does is it takes every element in the list and tries to add it to the set. Right? If it finds a duplicated element, it doesn't add the element a second time. Right? It just keeps on going and processes the rest of the elements in the set. Right? And so unique account, that's a set of all the unique accounts. Right? If you want to sort, if you want a sorted set of unique accounts, right, you just call the tree set constructor instead, right? Or you just make a tree set instead, and that gives you a sorted set of unique account names. Right? And finally, if you want to make sure that the order of the names in the original list match the order of the names in the set, use a linked hash set instead. Okay, so that gets rid of the duplicated elements. Now suppose I want to find the duplicated elements. Right? And so the trick here is you use two sets. Right? So again, CS account, that's a list of account names. Right? I'm going to make two sets this time. Right? I'm going to make a set of unique accounts. I'm going to make a set of duplicated accounts. Right? Both of the sets start out as empty. Right? So now what I'm going to do is I'm going to loop over the original list. Right? I'm going to try to add each element, each account name from the original list to the unique account set. Right? So for each account name in the list, right, I'm going to try to add that account name to the set of unique accounts. Right? So the add method for set returns true if the element is successfully added to the set. Right? It returns false if it's not added to the set. Right? Or in other words, it returns false if the account name is already in the set. Right? So If I try to add the account name to the set of unique accounts and it fails, I know this must be a duplicate, right? So I just add that account name to the set of duplicated accounts. And I don't care about the return value here, right? So if an account name is duplicated 100 times, right, it only shows up once in the duplicated accounts. Right? And similarly, it shows up once in the unique accounts. Right? So use two sets, process each element of the original list, and you get the set of unique and duplicated accounts. Right? So this is a picture of what it looks like. Right? So here's my original list of account names. Right? Notice that SP Kuma and D Parrot, they're repeated twice, or they're not unique. Right? So you're going to loop over that list. Right? And as I loop over the list, I'm going to try to add them to unique account. Right? So you start the loop, right? So first account name, empty set, so it gets added to the set. Right? Second account name, D Parrot, they're not in the set, so they get added to the set. Right? HP1304, not in the set, so they get added. Right? So right. Fourth account name, not in the set, so it gets added. Right? Now, when you try to add SP Kuma to the set again, right, it finds that it's already in the unique account set. Right? So it doesn't add it again. Instead, it adds it to the set of duplicated accounts. Right? And similarly with D Parrot. Right? You try to add it to the unique accounts. Right? It's already there, so add fails. Right? Add it to the duplicated accounts. Right? And there's your two sets. Right? There are the students who are in, there are the unique student names, and there are the ones that are duplicated. I guess when I say, sorry, so these are the account names of everybody that's in this set, in this list, right? And these are the account names of the ones who are also duplicated. Okay, so this is the set union operation, right? So if you know what a mathematical set is, right, then this method basically performs the mathematical set union. Right? If you don't know what the union is, if you don't know what the union operation is, then just look at this problem here. Right? So I have a set containing the accounts of students who completed assignment 1. Right? I have a second set of students a second set containing the account names of students who completed assignment 2. Right? And I would like to know who completed either assignment. Right? So they either completed assignment 1 or they completed assignment 2. Possibly they completed both. Right? If you want to know the answer to that question, you compute the union of the two sets. Right? So the union method is add all. Right? If I have a set S1 and a set S2, right, then S1 add all S2 tries to add all the elements from S2 to the set S1. Right? So it transforms S1 into the union of S1 and S2. Right? If there are elements in S2 that are already in S1, right, they don't get added a second time. Right? So if S1 is the set of students who completed assignment 1, and S2 is the set of students who completed assignment 2, I want to know who completed either assignment. Right? I make a new set, copying S1. Right? And then add all of the students who also completed S2 to either assignment. Right? And that produces the set of all students who completed at least one of the two assignments. Right? Here I'm making a new set so that I don't destroy the original set S1. Right? If you don't care about destroying the original set S1, then go ahead and just use S1. Okay, so the way this works is, right, so the first step is make a copy of the first set. Right? So there's S1, there's S2, here's my copy of the first set. Right? Now you're going to, now add all is going to iterate over the second set, and it's going to try to add each username to the either assignment set. Right? So, is SP Kuma in this set? The answer is yes. Right? So it does not add that name. Right? Is D Parrot in this set? The answer is yes. Right? So it doesn't add that name. Is Who's E in this set? The answer is no. Right? So Who's E gets added here. Is dev C in this set? The answer is no, so they get added here. Right? And so there's your set of names who have completed either assignment. Okay, so the set intersection, this is the same thing or similar to the mathematical set intersection operation. Right? If you don't know what the set intersection operation is, then just look at the following problem. Right? So I have a set of students who completed assignment 1, second set of students who completed assignment 2, and I would like to know who completed both assignments. Right? And so that's where you use the intersection. Right? Retain all is the set intersection method. Right? So S1, retain all S2, right? Keeps everything that's in S2 in S1. Right? So in other words, it looks at the elements of S2. Right? If it finds an element of S2 that's not in S1, then it doesn't add it to S1. If it finds an element in S1 that's not in S2, it removes it from S1. Right? So that transforms S1 into the intersection of S1 and S2. Right? So the set of students who completed both assignments, I'm just going to start by copying the first set, right? And then call retain all, passing in the second set. Right? So picture what this looks like is, whoops, here we go. Right? So that's a copy of that. Right? Now we're going to look at the elements that are here. We're going to look at the elements that are here. Right? And we're only going to keep the ones that are in both. Right? So, is SP Kuma in set 1? The answer is yes, so it stays. Sorry, I guess is SP Kuma in both assignments? The answer is yes, so it stays. Right? Is dparrot here? The answer is yes, so it stays. Right? Is who's-e in this set here? The answer is no, so it does not get added. Right? Is dev-c in this set here? The answer is no, so it does not get added. Right? Now it goes back in the other way. So is HP1304 in this set? The answer is no, so it gets removed. Is Arian 98 in this in S2? The answer is no, so it gets removed. Right? And you end up with that set there. And I think finally, yes, the set difference. Okay, so the set difference is, again, the same as the mathematical notion of set difference. Right? So an example problem would be, I have a set of students who completed assignment 1, I have a set of students who completed assignment 2, and I would like to know who only completed assignment 1 or who only completed assignment 2. Right? So that's the set difference. Right, so here I wanted to compute the difference S1 minus S2. And so that's the remove all method. Right? S1 remove all, S2 removes all the elements from S1 that are in S2. Right? So it transforms S1 into the set difference of S1 and S2. Right? If I don't want to destroy S1, no problem, just make a copy of S1. Right? Then call remove all. To get the set difference. Right? So there's my copy of S1. I'm going to process each one of these elements. Right? If this element shows up here, I'm going to remove it. Right? So does SP Kuma show up here? Yes, so it's going to get removed. Right? Does dparrot show up here? Yes, so it's going to get removed. Does who's-e show up here? The answer is no. So it does not get removed from the first set. It also does not get added to the first set. Right? Does dev-c appear here? The answer is no. So it does not get removed from here, and it does not get added either. Right? And so this produces the set HP1304 and Arian 98. Right? It keeps only the ones here that are not in here. Oops, sorry. Right? And so there is a very quick introduction on how to use a set in Java. So again, sets aren't often used just on their own. Normally you encounter a set when you try to use a map, because using maps is a lot more common than using it just a plain old set. Right? It turns out that in Java, Java builds a map by by using a set. And so I guess in the next lecture, we'll look at how to use maps. And I guess for the rest of the day, we'll call it quits.